Per usual, I just want to remind you that you do not need to write down everything that I have here, right? You do not need to write all that business down. You should write down what you think is the most important / would be the most helpful for you when you're looking back at your notes, okay? It looks like most of us have voted. Many of us are ready. Some of us need a minute. So it's been 49 seconds so far. So I will give you about 10 more seconds. If you're already ready, feel free to start writing. I would start with this as your title. All right, let's do this. If you're one of my 3 people who need a couple extra minutes, that is okay. If you, for some reason, are not able to, if you are not able to like catch up with me, or you want to jump into a breakout room to do your notes, you can do that if you wish. Your breakout rooms are open, so feel free to jump into them. Hopefully, there we go. Will come back. All right. Today, y'all, we're gonna learn a new and improved SOHCAHTOA. How many people remember SOHCAHTOA? Either raise hand, pop an emoji in the chat, whatever you got. Do we remember SOHCAHTOA? Sine, cosine, tangent. We remember. Yes. Amazing. Amazing, amazing, amazing. Thank you, thank you. All right, you can put your hands down if you had it. So we have sine, cosine, tangent. I have a goal that is a content objective, and then I have a goal for our class today. One is that students will be, like our goal for today is that you'll be able to solve missing sides and angles of right triangles. Okay, we're gonna do that on a coordinate plane like this. Okay, so we're gonna start by working with this coordinate plane, and we're gonna be dealing with sine, cosine, and tangent. Today, you might remember that we had at one point, like, if this is my angle, then I go across, this is my opposite, this is my right angle, I go across from that, that's my hypotenuse, and the leftover one is my adjacent. Do we remember this? Yes, yes. Yeah, I think so. All right, so we're gonna use this same process, but we're gonna use it on a coordinate plane. So the first thing to notice is how they are numbered, okay? This right here, right, the positive x-axis is where we start. That is 0 degrees. Then we move in a counterclockwise direction. This might seem kind of not intuitive, I understand, but we move in a counterclockwise. So if I went up this far, this would be like 45 degrees, halfway between 0 and 90. Right? Then I would have 90 degrees, all the way to 180 degrees, which makes sense because of a straight line is 180. 3/4 of the way would be 270. All the way around would be 360, right? So you could also say that this is 0 degrees, but it's also 360 degrees, right? All the way around that circle. So this is how we label our coordinate plane, okay? And when we talk about angles, let's say we talk about this one here. We talk about this angle. I'm talking about this point basically on a big circle like this, right? That point on a big circle. What I'm going to do in order to, we're thinking about it on a circle, but it really is a triangle, and here's why. We're dropping this straight down, a perpendicular line, straight down to our x-axis. That's going to create a 90-degree triangle. Notice how this triangle looks a lot like that triangle. Right? Looks a lot like that one that we've been using with SOHCAHTOA. We're still going to have our angle in here. This will be our theta. But now here's what's very cool. I can call this distance the bottom. I can call this x because it's a distance from 0 to out here on the x-axis. This is my x distance. From the 0 on the y all the way up to the top here, this is y. Right? So x y. And then remember how I told you this was a circle, right? There's a circle here, this point on a circle all the way around. From the center, does anyone remember the math word from the center of a circle to the outside of the circle? Halfway from the center to the outside? Halfway across the whole diameter? What's the word that we use? Yes, Gali, Axel, and Walter, great job, radius. How many use R here? So I have X, Y, and R for radius. So instead of using SOHCAHTOA, the O, the opposite, and the opposite, the adjacent, and the hypotenuse, instead of using it like that, we're going to use our grown-up language. Our grown-up language is going to be X, Y, and R. Right? We can use these same ones no matter where our triangle is. So let's say we're trying to find an angle that's over here. Say we're trying to find an angle that's over here. We're going to drop that line straight down and draw this over here. We still will have our theta in here for our angle. It will still be off of the origin. We'll still have our radius over here. We will have our positive y over here. And we will still have x over here. We'll still have x over here. What is different about x on this side, though? Is x, yeah, Galilee, it's negative, right? This was positive x over here. This is negative x over here. So if I'm talking about this triangle, I now have a negative x and I have a positive y. For sure, Diana, for sure, Galilee. Right, and you can imagine, you don't necessarily have to draw these, but you can imagine if I had a line that went out this way and here, I would have that same negative x. Now I would have a negative y. Right, so I would have a negative x and a negative y since it's headed down. And the same would happen if I was over here. If I was over here, drop that down, I would have a negative y and a positive x. My radius is always going to be positive. It's a distance from the center to the outside. It's always going to be positive, even if no matter what x and y are. It's always going to be positive. All right, so thinking about sine, right? Thinking about sine, now that we know how triangles are labeled on this graph, thinking about sine, it used to be O over H, right? It used to be opposite over hypotenuse. But now looking at all of these triangles, if my angle is always in the center here, what letter is always opposite? What letter is always opposite of my angle? Y. Yeah, Y over here, right? So opposite is really Y. And what letter is always my hypotenuse? R. Yeah, the radius is my hypotenuse. So sine, instead of being opposite over hypotenuse, is going to be Y over R. Miss Nelly has a really funny way of thinking about this. She said sine, right? She says it really funny. Sine. That's how she remembers that Y is on top. I don't know why. That is what she does. It's awesome. She says it every time, and I laugh, but I also go for it. It's kind of like the finger trip that I was thinking with exponentials, right? Sine, right? So sine is Y over R. Well, cosine used to be adjacent over hypotenuse. What is it going to be now? What is going to be our grown-up way of talking about it? What is our adjacent here? Yeah, our adjacent is x, and Kimbo's totally right. It's x over our hypotenuse, which we already know is our r. So it would be x over r. So cosine is x over r. So if I'm at this angle, my adjacent's over here, my x. If I'm at this angle, my adjacent's right here, my x. If I'm at this angle, my adjacent's here, my x. No problem, Gal. You're good. All right. So then, since we're not using this anymore, now tangent used to be opposite over adjacent. what is tangent going to be? What was my opposite? And my opposite is y for sure, and my adjacent is x. So I would have y over x like that. We're not going to use opposite over adjacent. Now we're going to use y over x. So now our sine is y over r. Don't get it, but I like it. Cosine x over r, tangent y over x. Something interesting is that this technically tangent is sine divided by cosine. This is sine over cosine. We're not going to get into that today. All right, so if I'm thinking about my updated Pythagorean theorem, right? Our baby Pythagorean theorem, a squared plus b squared equals c squared. What would our updated Pythagorean theorem be? If we were using x, y, and r, what would I say my Pythagorean theorem is if I'm using x, y, and r? Feel free to come off mute if you'd rather not type. Kayla's already got me in the chat. Yes, absolutely. It'd be x squared. I'm going to put x just because I like it better. Plus y squared equals r squared, for sure. X squared plus y squared equals r squared. Amazing. All right, we've been doing a lot of talking and a lot of like interesting things, talking about interesting things. Tell me, how are you feeling about this though so far? Are you like, what the heck is happening? Or are you more like, okay, I think I get this? I encourage you, if you're like, what the heck is happening? I encourage you to think about, what is your question? What question should you ask in order to clear up some of your understanding? Awesome. Looks like lots of 3s and 4s. I'm feeling pretty comfortable with that. I think we'll feel better once we have some things. I have to get comfortable with it. Yeah, for sure. It just feels kind of funny right now. All right. So we are going to learn how to draw our triangles in the right quadrants, and then how to use our updated Pythagorean theorem in order to solve for the missing side. So I'm going to go ahead and give you a moment to write down this one. You don't need to write down the question. Let's take a moment to write down A and B if you have a chance. All right, I'm going to need some help. If you are able to come off mute to answer my question, if you could go ahead and press that raise hand button so I know that you are available. Thanks, gallery, for pressing that raise hand button. If you are able to come off mute, that means like it's not super loud in your background. It's okay if it's a little loud in your background. Thanks, Devin. Thanks, Eric. Thanks, Mia. Thanks, David. Thanks, Walter. Thanks, Axel. Cool. Devin Z, can you read the directions where it says example 1, please?
Draw the triangle described in its proper quadrant and find the length of the missing.
Missing side, for sure. Thank you. So drawing a triangle described in the proper quadrant, right? So that's the first step. And then the second step is going to be to find the length of the missing side. So first we need to put it in its proper quadrant, and then we're going to find the length. Okay. So looking at this first example, we have sine theta equals 12 over 13. And then it tells us the quadrant. That's what's happening here. It's telling us the quadrant, right? So knowing that this is labeled 1, 2, 3, and 4, which quadrant is from 0 degrees to 90 degrees? Yes, for sure. It's number one, yeah. So it's going to be this one here. So I am going to draw my triangle over here. I don't know theta, so I'm just really drawing like a straight up, just like a line anywhere. I could draw it here, I could draw it here, I could draw it here. Makes no difference because I don't know what theta is yet. I'm going to go ahead and drop that perpendicular so that I actually have a right triangle here. And I'm going to label theta. right? So I've drawn my triangle. Right? And then it says, find the length of the missing side. Okay, so I need to figure out the lengths of the sides that I do know. Sine theta equals this over this, right? Mia Hernandez, can you take a look at your notes and tell us sine is what over what? Like, is it X, is it Y, is it R? Sine is what over what?
Sine is Y over R.
Absolutely, thanks, Mia. Y over R, like that, right? So 12 is Y, and my radius is 13. So 12, I'm gonna go over here, put a 12 here on my graph, and then my radius is 13. So the radius is here, 13. So I have two of the sides. So then I need to figure out what this side is to answer my question, right? I'm trying to figure out that side there. How could I figure out that side there? Anybody feel free to come off mute or put it in the chat.
Using the Pythagorean theorem, the updated one?
Absolutely. Thank you. So we're using my Pythagorean theorem. So I have x squared plus y squared equals r squared. I don't know what x is, so I'm putting in x here. I know what y is, it's 12, so I'm putting in 12 squared equals r squared 13 squared. I don't need to like actually figure out what they are. I'm just gonna move 12 squared over like that. So I have x squared equals, and then I might go to my calculator, 13 squared minus 12 squared. I already know that this is 169 minus 144 would be 25. What does that mean that x is? It is a perfect root, 5. This is what we would call a Pythagorean triple. If you've ever like memorized them, I think in Miss Wall's class it was like 3, 4, 5, 3, 4, 5, and she made you like clap and guess them at the same time. If you weren't in Miss Wall's class, you might have been like, okay, I'm just supposed to memorize these. But there are some, if you know that it's 12 and 13, you know that the other side is 5. So it's 5, 12, 13, 5, 12, 13, or like 6, 8, 10, 6, 8, 10. There's a bunch of them. I have them like stuck in my head from Miss Wall, so that's my favorite way to think about them. So x is 5. The only thing here is would x be positive 5 or negative 5 if it's on this side of the graph? Positive. Yeah, it's going to be positive. So we have 5, 12, 13. So let's double check the directions real fast. Did we draw the triangle described in the proper quadrant? Yes, we did. Did we find the length of the missing side? Yes, we did. So we are done with this problem. Our answer is 5. Well, our answer is this triangle for the first part and 5 for the second part. All right. Let's jump into this next one. I want you to go ahead and try to draw the triangle. All right, so we have tangent theta equals 40 over 9. 40 over 9. For this one, I didn't add them. Oh, good question. I didn't add. This isn't 13 minus 12, like, or 13 plus 12. That's not how I got 25. This was 169 minus 144. Gave me 25. It just happened to be that way. It's just a coincidence. 13 squared. Yeah. Oh, good coincidence. I didn't notice that. Welcome. All right, we're trying to draw this one here. Okay, 1, 2, or 3. Walter, can you tell me which quadrant I would draw this in and how you know?
Quadrant 3.
Good job. How did you know quadrant 3?
Because it says 270 and 180.
Perfect. Thank you, Walter. So 0, 90, 180, 270. We want this section here. All right. So I have my line drawn here. I'm going to draw a line straight up here. Anybody can come off mute. Help me. How can I figure out what side length to put here. What numbers did I put on my triangle? Devin,
Tangent
talk to me.
is, oh,
Oh, go ahead, Gally. Go ahead, Gally.
tangent is y over x. So you have 40 as y, and then you have 9 as x. Well, -9 since it's on the other side.
But if I have -9, that's going to change the problem. What else do I have? Yeah,
Negative
Kimbo. Yes, Gally, -40, right? So my answer, yeah, was +40 over +9. But the reason that that is because these negatives cancel, right? So if I'm in this quadrant over here, then I would need to have negative, right? -40, -9. Perfect. Awesome. Thank you, Gally, for setting that up for us. I have theta. So now my last side that I need to figure out is my radius, right? My radius. David Lopez, can you talk to us about how I can figure out my radius?
You would use updated Pythagorean theorem. So x, you would use 9 squared. Then you would add it by -40 squared, since it's your y. And then you would equal that to r squared.
For sure. Thank you, David. Thanks, Jimmy. Sometimes I see your name and I forget. All right, so we have -9 squared is going to make 81. -40 squared, 4 times 4 is 16 with 2 zeros, right? Equals r squared. For the sake of time, I'm going to tell you this is 1681. Does anyone know square root 1681? 41, absolutely. 41 equals r. Right? 41 equals r. It's going to be right here. So instead of r, I'm going to have 41 as my answer. So the first part of my answer is the graph. And the second part of my answer is the like this side, like the missing side. Okay. I'm going to relaunch this poll. How are we feeling about this after seeing these two examples? All right, looking good. Cool. Okay, in the interest of time, and because I think that we are here, I'm going to go ahead and move past C and D. C and D are both in the video. So if you need to check out the video, they are there. I did it all the way out. I did them last night, so you can check them out if you're interested or if you get stuck later on. Okay. So example 1, this will be like number 1, the number 1 problems on your homework. Okay. But I do have 2 and 3, so I want to show you each of those. So we'll do 2 for number 2 here, and we'll do 2 for number 3. Can I have Axel? Axel, can you read the directions for example 2?
Use the appropriate trig function to find the missing side.
Amazing, thank you. So we're going to use trig, and we're still going to find that missing side. So for A, right, for A, we have our theta here, right? We have theta. They tell us we want y, and we have our radius, right? So if we have y and radius, which of the 3 functions, sine, cosine, or tangent, are we going to use if we have y and r? We have y and r. Yes, Araceli, good job. We have sine. We're going to be using sine because sine, remember, is y over r. Sine, y over r. Cracks me up every time. So I have sine of an angle, right? Sine, remember, always comes with an angle. So the angle I'm going to use is 37. And then just like we used to do with SOHCAHTOA, we're going to write the fraction. So I have the y is going to go on top because it's y over r, which in this case is 15. 15. Eric, tell me, how can I get y out of here? If I have y divided by 15, how do I get y by itself?
Multiply both sides by 15.
Perfect. Multiply both sides by 15, like this. So I have 15 times sine 37. One note here, when you go to your calculator to actually calculate what it is, one note is that your calculator needs to be in degrees. Decimals will default to radians. So you're gonna have to click on the little tool. It will, like when you first open it, be on radians. So you wanna switch it over to degrees. I already switched it because I was working on this with Algebra 2 today. So we're gonna type in just 15 times, and then you can go to functions, click sine. You can type SIN if you're on your computer, sine 37. And I'm gonna use 3 decimal places per usual. So I would have 9.027 equals y. Goes by like that. So this side over here would be about 9.27. That is my answer for this one. Since they asked me to find them sync side. Any questions about this one? I'm gonna go ahead and show you the next one. Cool. I'm gonna give you 1 minute. I want you to try this one on your own. I want you to find, you're finding y over there. Finding y over here. Go ahead and try this one on your own. You're setting up the equation and then solving. All right, anybody want to do this problem for us? Feel free to mic pop. I have theta here, right? Theta here. Yes, Gally. Yes, Mia Lopez. I'm going to be using tangent because tangent is y over x. And I have my y and I have my x. So I'm going to be using tangent. Diana's telling me I would use tangent 61 equals, she's using negative y. I'm going to put y here. I know it should be negative. I'm just going to use regular y for now. And then -9 can go here. That is my x. If you put a negative here, it will just tell you the positive version. It's not a big deal because I know on my graph, I'm going to be putting the negative. One caveat here, the distance is always going to be positive. So if you're talking about a distance between two things, I'm not -16 feet from you. That doesn't make any sense, right? I would just be 16 feet from you. However, on this particular graph, if we're talking about a graph, we could be a positive or a negative because it's dependent on that center origin, right? Moving to the left or right or up or down. So it'd be positive or negative. So I'm going to go ahead and multiply by -9. Here I have -9 times tangent 61. Notice it's going to give me that negative answer there. I have this -9. So I would have y equals -16.236. -16.236, which makes sense because y is negative. And so I could have that as my y. If you don't put in the negatives, it's not a big deal. It's just going to tell you positive 16.236, and then you're going to know since it's the negative direction for the y here in this quadrant that it would be a negative answer. Negative answer there. Okay. All right. I do want to show you number 3. Number 3 is exactly the same thing. We're still using an appropriate trig function to find the measure of the angle this time, right? So you'll probably remember this from SOHCAHTOA. We're still going to label, I'm going to say, okay, this is my y, this is my x. So since I have y and x, am I going to use sine, cosine, or tangent with y and x? Tangent, yes. So tangent of theta is y over x. So I'm going to have tangent of theta. I don't know theta this time. This time that one is my unknown. And my y is 12. My x is negative 12. I can use positive 12 if I want. And now I know tangent of theta. I can simplify this as negative 1. How do I get rid of tangent? Does anyone remember? How do I get theta by itself? Get rid of tangent? The inverse, yeah. Yeah, the inverse. Tangent, it's this one that has like the negative 1, kind of looks like an exponent. And I need to do that on both sides of tangent negative 1, like that. So in my calculator, I can't, I would like to just type in tangent and exponent, but actually I have to go to functions and I'm gonna choose one of the tangent ones here. So I'm gonna choose this one right there. So I'm gonna go down and choose tangent and then put negative 1 in there, right? Negative 1. I get negative 45 degrees. If you just put in the 1, you get positive 45. Then this angle here is a positive degree, right? 45 degrees. Positive. It's positive just because angles are positive. Angles and radiuses are positive. X's and Y's are what is possibly negative. Degrees will always be positive. Yeah, Devin, they'll always be positive. So even if you get a negative answer, you're still going to talk about them in positive degrees. There are such things as negative degrees, but we'll talk about them later. I'm going to let you use 1 minute to do this one. I will do it at the same time. 1 minute to do this one here. And we'll release you. In this case, I have X and R. So I'm going to be using cosine. So I have cosine of theta is negative 24 over 25, like so. I'm going to use the cosine negative 1 to get rid of that, leave me with just theta. And then I'm going to go to my calculator. Oh, yeah, y'all, thank you. Yes, Ale, yes, RSLA, yes, Eric, yes. I do mean Y. That's silly. What was I thinking? Y. Okay, so then that changes it. Yes, RSLE to sine. So we're going to use sine inverse. Thank you for everyone who corrected me. Just seeing if y'all were still awake, still paying attention. Absolutely. That makes me feel like you actually know what you're doing, which is great. Negative 24 over 25, we get 73.7, 738. Nope, 740. So this would be 73.9, but we're rounding it up, right? We have that 73 and then 9 is going to make it like 74. So we have 740 here. Ooh, good thing your brain was not breaking. Good thing, good thing. All right, my friends. Again, if you want to see all of the examples, you can head to the video that I posted for this one. For your assignment, you already have done the notes. The notes video is in the notes page if you need to see that video. You are going to have number 1, right? Number 1 is going to be exactly like example 1. Number 2, exactly like example 2. Number 3, exactly like example 3. You're going to post your work here. And then the last piece, as we've talked about, numbers 4 and 5, you're either doing 4 or 5, but as we've been talking about, part 2 is trying to stretch your brain a little bit, right? So you might feel a little less confident on 4 and 5, but numbers 1, 2, and 3, you should be good to go. Okay. I love you. Happy weekend. Happy Friday, Junior. If you have any questions, we'll be here from right now until noon. So come before or after Spanish. All right, team. I will see you all later.